Some natural phenomena. Introduction. Nature is mysterious and unpredictable. There are various natural phenomena that take place around us all the time. Some of these are thunder, lightning, winds, earthquake, etc. During a thunderstorm, you must have seen flashes of lightning accompanied by loud thunders. An American scientist, Benjamin Franklin, showed that clouds have electrical charges. He flew a kite in the thunderstorm and tied a key to the other end of the string. He observed that electricity from the clouds passed through the wet string to produce sparks on the key when touched by a metal rod. He explained that lightning and sparks from the clouds are the same phenomenon. However, it took 2000 years for this realization to be proved. When two bodies are rubbed together, the free electrons are transferred from one body to another. On rubbing, the body which gains free electrons becomes negatively charged, and the body that loses free electrons becomes positively charged. It must be clearly understood that the electrification is not because of the transfer of protons but because of the deficiency of electrons. Different ways of charging a body. Charging by friction. When two different bodies are rubbed together, there is friction between them that charges the two bodies. When you rub a glass rod with silk, the glass rod acquires a positive charge, whereas the silk cloth acquires a negative charge. This method of charging a body by friction is known as charging by friction. Charging by conduction. A body can also be charged by touching it to the charged body. This happens because some charge from the charged body gets transferred to uncharged body. This is known as charging by conduction. Charging by induction. A body can also be charged by bringing a charged body just near it without even touching. In this case, the body being charged acquires an opposite charge to that of the body charging it. Electric charge can be transferred from a charged object to another through a metal conductor. A device based on this principle is electroscope, which is used to detect and measure electric charge of an object. You can make your own electroscope to detect if a body is charged or not, as demonstrated in Activity 1. Here is an activity showing how a simple electroscope is made to test whether an object is carrying charge or not. Take a glass bottle with a wide mouth. Cover it with a piece of cardboard. Make a hole in the cardboard and pass a metal wire through it. Blend both the ends of the wire as shown in the figure. Cut the strips of aluminium foil and hang them on the lower end of the metal wire. Touch a negatively charged ebonite rod to the upper end of the iron wire. We observe that the aluminium strips repel each other. This happens because strips get charged negatively by conduction when touched with the ebonite rod. This arrangement can be used to detect if an object is charged. It is also used to measure the charge by noting the amount of repulsion it produces between the two strips. Lightning and thunder. During a thunderstorm, the huge masses of clouds get electrically charged. This is caused by rubbing of the clouds with each other and due to the presence of dust in the air. When two charged clouds come in contact with each other, a large quantity of electric current flows between them. This leads to an intense spark of electricity which can be seen in the sky. This is known as lightning. Thus, lightning is a very heavy flow of charge between clouds or between the clouds and the earth, and this process is defined as electric discharge. Lightning is accompanied by a thunder. It produces a large quantity of heat. The electric discharge also generates lots of heat. This generated heat causes heavy air currents to flow, leading to the disturbance in the surrounding atmosphere. This sudden and heavy airflow produces loud sound, which is heard as thunder. Safety during lightning. A lightning strike is very dangerous as it might cause loss to life and property. Following measures are suggested during lightning strikes. It is advisable not to remain in an open space and take shelter under a safe place when you hear thunder. Taking shelter under a tree is not safe as lightning can strike the tree. If you are forced to take shelter under a tree, example, if you are in a forest, choose a short tree. It must be ensured that tall buildings are fitted with metal lightning conductors. It is safer to switch off electrical appliances. In case you are traveling, you should prefer to stay in your car or a bus with windows and doors of the vehicle shut. If caught in an open place, stay away from trees and poles. If you cannot find any shelter, squat low on your body. Place your hands on your knees with your head between the hands. This position will make you the smallest target to be struck. Carrying an umbrella is not at all a good idea during thunderstorms. During a thunderstorm, lightning can strike telephone cords, electrical wires, and metal pipes, and so contact with these should be avoided. Bathing should be avoided during thunderstorms to avoid contact with running water. Electrical appliances like computers, TVs, etc. should be unplugged. Electrical lights can remain on. They do not cause any harm. Some natural phenomena during lightning. Lightning gives rise to a number of natural phenomena. Some of them include nitrogen fixation. Because of the intense quantity of energy released during lightning, the atmospheric nitrogen combines with the atmospheric oxygen, resulting in the formation of oxides of nitrogen. Oxides so formed combine with the falling rainwater, resulting in formation of nitric acid, which falls on the earth as acid rain. It then seeps inside the earth and reacts with some alkalis present in the soil, resulting into the formation of nitrates. These nitrates are then used by plants for their growth. Ozone formation. Ozone, O3, is formed from oxygen, O2, during an electric spark. It is the ozone that is responsible for the absorption of ultraviolet rays of the sun and the protection of living beings on the earth. The lightning conductor. As we know, lightning can cause a lot of damage to tall trees and buildings and can even cause fire. Thus, tall buildings need to be protected against lightning. To do this, architects install lightning conductors at the building rooftops. Lightning conductor is a device used to protect buildings from lightning effect. A lightning conductor is a long and thick metal rod having sharp spikes at the upper end. The part containing the spikes is placed at the highest point on the building. The lower end, which consists of a large copper or aluminium plate, is buried deep inside the earth. This is called earthing. Because of this, excess charge flows into the earth as both rod and metallic plate are good conductors of electricity. When a cloud carrying a heavy charge passes over the building, it finds a way down to the earth through this lightning conductor and thereby prevents the building from any damage. Earthquake. An earthquake is a sudden shaking or movement of the earth which lasts for a very short time. To understand the cause of earthquake, we first need to understand the structure of the earth. Structure of the earth. The structure of the earth can be studied under the following two headings. The earth's surface. The earth's surface, as we can see, is not smooth. Rather, it has hills, mountains, lakes, rivers, seas, oceans, plains, and plateaus. By and large, the earth appears to be spherical in shape. Inner structure of the earth. The inner structure of the earth mainly consists of three layers: crust, mantle, and core. The crust is the thinnest and the outermost layer of the earth, which is 71% covered by water. Life on the earth is mainly supported by the crust. The mantle extends down to the depth of about 2,900 km from the base of the crust. It is mainly made of iron and magnesium. However, in the inner layer, molten matter called magma is present. The core is the innermost region of the earth. The radius of the core is about 3,400 km. The temperature of the center of the earth is around 4,000 degrees Celsius. Causes of earthquake. The main causes of earthquakes are the following: volcanic eruptions. The sudden release of molten lava consisting of rocks and hot gases under high pressure through a small opening on the Earth's crust is called a volcanic eruption. The movement of the molten matter inside the Earth causes vibrations which result into an earthquake. Man-made explosions. Nuclear explosions made by man can cause powerful explosions, which might be the source of an earthquake in that area. Dislocation or faults of the Earth's crust. At times, the crust of the Earth dislocates while resulting into a fault. The faults are zones of weakness in the Earth. The weak zones are also known as seismic or fault zones. This might cause an earthquake. Movement of tectonic plates. Lithosphere is believed to contain 12 crustal plates which float over the molten magma in the mantle. Most earthquakes occur at the boundaries where the crustal plates join with each other. Seismic zone. Seismic zone is an area on the earth where the earthquakes are prone to occur. These are mostly the boundaries where the plates of the earth meet. The boundaries of the earth's plates are the weak zones, and their earthquakes are likely to occur. These weak zones are called seismic zones. In India, the areas which fall in the seismic zones are Kashmir, Western and Central Himalayas, Rajasthan, etc. Magnitude and intensity of an earthquake. The magnitude of an earthquake is a measure of the amplitude of the seismic waves. This is expressed by the Richter scale. The number indicating the magnitude on the Richter scale ranges between 0 and 9. An earthquake of magnitude 4.5 is considered moderate and can disturb loose objects. At magnitude 6.5, an earthquake can damage weak structures. An earthquake of magnitude 8 or more can be highly disastrous. Both in Bhuj and Kashmir, the earthquakes had a magnitude greater than 7.5. The intensity of an earthquake is expressed by the modified Mercalli scale. This shows that how strong a shock was felt at a particular location. Factors on which earthquake depends. The destructive effect of an earthquake depends on the following factors: magnitude of the earthquake, local geographical conditions, distance from the epicenter, design of the buildings and other structures, density of constructions and population in the affected area. Effects of an earthquake. Earthquake may cause damage to buildings, roads, bridges, railway tracks, etc. It might cause landslides, floods, and tsunamis. It might cause damage to underground gas pipes or water pipelines. It might even cause loss of life and enormous destruction. Protection against earthquake. It is very difficult to predict the occurrence of an earthquake as it occurs suddenly. However, we can take following precautions against earthquakes while building our houses. In highly seismic areas, use of timber is better than bricks and concrete. Roofs should be made as light as possible. Buildings should be made quake-safe by constructing them according to earthquake-proof norms. Firefighting equipment should be installed and kept in working order. You should take following precautionary steps if you are caught in an earthquake. If trapped in your home or a building, take shelter under a table and do not move till the shaking stops. Protect your head with your arms. Do not sit inside a car or bus. Do not stay near the windows, mirrors, hanging pots, fans during or immediately after an earthquake. If outdoors, keep away from high-rise buildings, trees, poles, and electric wires. Help others according to their needs.